What if black holes are portals? Black holes are mysterious. They're invisible, they devour light, and once something crosses the event horizon, it's gone forever. Or is it? What if black holes aren't cosmic dead ends? What if they're actually portals? Gateways to other places, other times, or even other universes? Today we're exploring one of the wildest ideas in theoretical physics, the possibility that black holes might be tunnels through space-time. What is a black hole? Before we talk about portals, let's quickly review what a black hole actually is. A black hole forms when a massive star collapses under its own gravity, compressing all its mass into an infinitely small point called a singularity. The gravity is so intense that nothing, not even light, can escape from within a boundary called the event horizon. According to Einstein's general relativity, a black hole warps space-time so severely that it creates a one-way trap. Anything that falls in is crushed to oblivion at the singularity. But here's where it gets interesting. Einstein's equations don't just predict black holes, they also predict something else, something stranger. Wormholes, Einstein-Rosen bridges. In 1935, Albert Einstein and physicist Nathan Rosen discovered a solution to Einstein's field equations that described a theoretical structure connecting two separate points in space-time. They called it an Einstein-Rosen bridge. We call it a wormhole. Imagine space-time as a flat sheet. A black hole creates a deep well in that sheet. But what if that well doesn't end at a singularity? What if it connects to another sheet, another part of the universe, or even a completely different universe? That's a wormhole, a tunnel through space-time. The math works, the equations allow it. But does it actually exist? The white hole problem. Here's the challenge. If a wormhole exists, the other end can't be another black hole. If both ends were black holes, nothing could ever come out. Instead, the other end would need to be a white hole, a theoretical object that's the exact opposite of a black hole. While black holes pull everything in, white holes would push everything out. No white holes have ever been observed, and most physicists think they probably don't exist in our universe. Without a white hole on the other side, a wormhole wouldn't function as a portal. You'd fall into the black hole and just be crushed at the singularity, the traversable wormhole. But what if we could stabilize a wormhole? Keep it open long enough for something to pass through. In 1988, physicist Thorne, who later won a Nobel Prize and consulted on the movie Interstellar, worked with colleagues to design a theoretical traversable wormhole. The conclusion? It's possible, but only if you have exotic matter. Exotic matter isn't regular matter. It has negative energy density, meaning it would have anti-gravitational properties, pushing space-time apart instead of pulling it together. Exotic matter would act like scaffolding, holding the wormhole open and preventing it from collapsing. Do we have exotic matter? No. Does it even exist? We don't know. The Casimir effect, a quantum phenomenon where two metal plates placed extremely close together experience a tiny attractive force, hints that negative energy might be real, but we're nowhere near being able to produce it in useful quantities. Rotating black holes. But there's another possibility. Not all black holes are the same. Some are rotating, called Kerr black holes, named after physicist Roy Kerr, who described them in 1963. A rotating black hole doesn't have a point singularity. Instead, it has a ring singularity, a donut-shaped structure. Here's where it gets wild. The math suggests you could pass through the ring without hitting the singularity. And if you did, you might emerge somewhere else. Where? That's the question. Some solutions to the equations suggest you'd pop out in another universe. Others suggest you'd travel backward in time. Still others predict you'd end up in a parallel region of our own universe. But there's a catch. The interior of a rotating black hole is incredibly unstable. Tidal forces would stretch and compress you, a process called spaghettification. And even if you survived that, the slightest disturbance would likely collapse the wormhole, trapping you inside. The information paradox. One of the biggest mysteries in modern physics is the black hole information paradox. Quantum mechanics says information can't be destroyed, But if something falls into a black hole and is crushed at the singularity, where does the information go? Stephen Hawking proposed that black holes slowly evaporate through Hawking radiation, releasing energy over trillions of years until they disappear. But that radiation appears to be random, with no information encoded in it. So where did the information about everything that fell in go? Some physicists think wormholes might be the answer. Maybe information isn't destroyed, it's transferred somewhere else. Maybe what falls into a black hole emerges from a white hole in another region of space-time. It's speculative, but it's one way to solve the paradox. Could we ever use one? Let's say wormholes exist. Could we use them? Probably not anytime soon. Even if we found a traversable wormhole, we'd need to stabilize it with exotic matter we don't have. We'd need to survive the tidal forces inside, and we'd have no idea where the other end leads. But here's the fun part. If an advanced civilization existed millions or billions of years ahead of us, they might have figured it out. They could, in theory, use wormholes to travel across the galaxy or even across the universe in seconds. It's the ultimate shortcut. What do we actually know? Here's the truth. We don't know if black holes are portals. The math allows it, the equations predict it, but we have no observational evidence. Black holes warp space-time, they bend light, they swallow matter, and they're some of the most extreme objects in the universe. Whether they connect to other places, that's still science fiction for now. But isn't that what makes them so fascinating? The takeaway: black holes might be dead ends, or they might be doorways. Until we can observe what happens inside an event horizon, or until someone builds a traversable wormhole and lives to tell about it, we won't know for sure. But the fact that the universe even allows such possibilities, that's what keeps us looking up. Like, share and subscribe for more cosmic mysteries, and as always, keep looking up.